Good morning. Welcome to microprocessor tutorial session. Okay. Today in this session, I will be discussing sheet 1. So let us begin with. The first question is, this is our sheet 1. You can just have a look. You can find this sheet in your Blackboard. Go to lectures folder. Okay. When you click on lectures, you will find all the sheets and the chapters which are taught by doctor in theory, and also in tutorial all the sheets are uploaded. It is better you just take these printouts for this sheet, so that in the tutorial session you can have paper in your hand and you can just see the question numbers and also note down the solutions. Okay. Got me, Muhammad? Am I audible? Do you able to hear my voice? Okay. So now let us start with sheet 1. Okay. I think in first week we may complete nearly 4 up to 4 questions this week. Maybe next week we'll finish the remaining up to 10 problems. Okay. In third week we'll start this physical and logical address calculations. Okay. So maybe we will go up to here. Okay. And fifth week we will start another sheet. With another sheet we will solve these two problems plus uh, sheet 2. Okay. So this is the plan. So let us start with problem number 1. Okay. Number conversions to different bases. Now yeah, I will just share the application now. Please go to the Blackboard and download this sheet, or if you have sheet, please open this sheet, because I will not come back to this sheet again and again. Okay, please note down that you download this sheet into your computer. Okay, I'm giving you time. Please download this from Blackboard. Go to lectures. In lectures, you will find this sheet. If you want, I will just show you. Okay, just go to this Blackboard. Click on this lectures. Okay, when you click on this lectures folder, you will see sheets and material. Okay, here you will see sheet 1, sheet 2, sheet 3. The sheet 1 corresponds has been prepared using chapter 1. Sheet 2 is prepared using chapter 2. Sheet 3 is prepared using chapter 3. Okay, and sheet 4 is in due. We will prepare it shortly. Okay, so please click on this link. It will open the sheet 1. Okay, you click one, then you will see the sheet 1 here. You have got it. Yeah, I understand that Blackboard is very slow. So it is better. The good trick is, if you log in before 5 minutes, you can do it very easily. If you start at 8 or 8:1, 8:2, it is very slow. 7:55, it is good. Okay. So when once you created the session, then it will work smoothly. So let me so do all of you open this sheet? I want all of you to open this sheet. Let us try to solve today these 4 problems. Okay. We'll try to solve these four problems in today's session. First problem is number conversion to different bases. The second problem is nearly informative about what is microprocessor. Okay. Then we will solve these two problems. Problem number 3, that for adding two 32-bit numbers in 8085 and 8086, okay, it takes how many clock cycles? And second is calculate the time required to execute an instruction that add two 32-bit numbers in 8085 and 8086. So hope all of you have downloaded this file. Shall I proceed? I'm waiting for your response. If you have downloaded this sheet, and please make this sheet open. Okay, thank you. So now let's go for solving first problem. Okay. Yeah. Okay. Do you able to see my screen? All of you? Do you able to see my screen? First solution. Okay. Thank you for giving response. So yeah. Now let us solve. There are two skills you need to learn in this number, conversions from one basis to. The first skill is you should know how to convert a number, okay, which is in base 10 to any base, okay. Have some number. Before that, I will just give you a definition of a number. What do you mean by a number? Number is not a number, is a number with base. A number is a number is a number with base. So all of you, please make sure that you take notes when I'm teaching. Okay. Now you see you have a number here. A number. Okay, whatever maybe the number is it. So I just denote a number with n. So this number is in base 10. So my goal is first to learn how to convert this number to base, any base. Okay, any base. This is my first skill. Okay, and second skill is you need to learn second skill. If you have a number with any base, then how do you convert this to base 10? If you note these two skills, then it is easy for you to understand, any number conversion. Okay. For example, yeah, have got any question? Yes, I am recording the lecture. Why do you want me to record or no record? Okay. Yeah. So now the thing is, if you understand these two skills, now if I ask you, for example, you have some number, from base 2, you have to convert this into, for example, base 7. How can you do this? It's very easy. Okay. So first, you know the skill to convert any base to base 10. So we will convert this into base 10, okay? And from base 10, you will convert it to 7, okay? So anything you can do now if you know these two skills, okay? So shall I go for next slide? Understood? Yeah. So now let us understand the first skill, okay? From any base to from base 10 to any base, a number with any base or n dash, okay, with any base. Let us, we will take some examples, okay? So let me save this. Yeah. So let us take an example of suppose if I want to convert, let me see an example. If I want to convert a number 153 of base 10 to number 99, okay? So I want to convert a number. First example I'm taking, there is suppose some number 153 which is in base 10, and I want to convert this into base 16, okay? Now remember, in this first skill, whenever you have a number in base and it is asked for you to convert this into base 16, what you will do is you just write down the number 153, okay? And what is the base you which to which you want to convert? This is your target base, okay? So write this target base here, okay? And now you divide it, okay? 16 goes how many times in 153? Please give me answer. 16 goes how many times in 153? Yeah, 153, if you divide it by 16, okay, 9 times it goes, okay? So 16 into 9, 16 into 9 is how much? What remainder you will get? How much? 16 into 9? 16 multiplied by 9 is 144, correct? And 144 means 153 minus 144 is remainder is 9. Remainder is 9, okay? Now you see, whenever you see that this number, okay, this number when it becomes, yeah, when this number becomes less than the base, this number is less than 16, okay, you should stop. You should stop and take the numbers from bottom to top, from bottom to top. So bottom you have number 99 and then next you have 99. So it means if you convert this in hexadecimal, you get 99 to the base 16. So the solution is, if you convert 153 of base 10, if you want to convert into base 16, it is nothing but you will get 99 to the base 16. Okay, understood all of you? You have any questions from this? Please ask. You have any questions? Okay, again, please. Yeah, I will explain you again, but I will take another example. Okay, so that we can cover more examples and it will be easy for you to stand. Okay, let us take a number. For example, okay, I will take 2597. Yeah, I see black screen. Now the screen is clear. I think I'm able to see the clear screen clearly in student window. Do anybody has this problem? Do all of you able to see my window clearly? Okay, so I will just save it and I will take a new slide, and this is first solution. Continue. Okay, clear. Okay, so we'll take another example. Okay, dear brothers, if you see that this video is small, on top you have some show view controls. You click on it and click plus zoom in, then the screen will become bigger. Okay, accordingly you can adjust this screen big or small. Let us take another example now. All of you, please be ready with the calculators. Okay, so we are learning the first skill. Sorry, I will use this pen and let us use this color. Okay, so still we are using the first skill. In that first skill, any number to having base 10 to convert a number into any base. Okay, so let us take example 2. Okay, what is example 2? Let us take mm, I will take one example 2 as okay, 25 2597. Let us take this example. 2597. Okay, this is in base 10 and I want to convert this into base 16. Okay, so now remember, in base 16 you need to know that in base 16 you have 16 symbols: 1 2 3 4 5 6 7 8 9. Okay, like this go on up to 9. After 9 you have 10, 11, 12, 13, 14, 15. It starts from 0. Okay, the first number is 0. So now 10, you don't write 10 as 10 in hexadecimal. You will write it as A. 11 you will write it as B. 12 you will write it as C. 13 you will write it as D. 14 as E. 15 as F. Okay, now let us uh, apply the logic. So what I have to do is I will write 2597. Okay, and I divide it with 16. Okay, tell me 2597 goes how many times? 2597 goes how many times in 16? Okay, now let's do it like this. 16 ones are 16. 16 means you have 25. So how much it goes? So, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 9. Okay, so you have carry 9 here. So I just write down with other color. You get carry here 9. Okay, so 99. 99 goes how many times? again. Okay, if you take 6, okay, total 162 times. Okay, so it goes how many? 162 times. 16 goes 162 times. 2592. 16 into 162 is how much? 2592. So what remainder you get? The remainder, how much you will get here? So you subtract 2597 from 2592. Okay, just 16 into 162 is nothing but 2592. Okay, this is 2592. So 2592, if you subtract 2597 minus 2592 minus 2597, how much you will get? 5. Okay, so remainder will be, yeah, remainder will be 5. Okay, but you see this 162 is within this 16, so I will divide it again. Okay, 16. Now tell me 16 goes how many times in 162? 16 goes how many times in 162? 10 times, correct? 16 into 10 is how much? 160. 16 into 10 is how much? 160. 160, but here 162. So remainder is 2, right? Now this 10 is smaller than 16, so we will stop here. We will stop. Why we will stop here? Because 10 is smaller than 16. Here we didn't stop because 162 is bigger than 16. Till this number quotient becomes lesser than 16, you should go on doing that. Okay, after doing this, now let us take, how do you take this number from bottom to top? Like this you have to take from bottom to top. If you take bottom to top, you have 10. 10 means how much? 10 is nothing but, it is A, correct? 10 is nothing but A. So you got A to 5. This is in 16. A to 5. This is in base 16. Okay. So therefore the solution, what is the answer here? You get A to 5. Correct? So anyone of you have any question? Do you understand this? Yeah, you just do it like this. Calculator. Yeah, how to calculate this in calculator? This is small mathematics. You see, you divide 2597 divided by 16. Okay, you will get 162. So you write 162. So 16 into 162 is 2592. So what is the remainder? You get 5. I think this is the maths you have done in schools. How do you find out the remainder, LCM, GCD? Okay, so the same stuff. Okay, if you have not understood, I will take one more example. Example number 3. Okay, shall I take one more example? This is A. Okay, let me take one more example. So I cut it and paste it here. Okay, so let me write another example here. Example 2. I think by this example you will understand. All of you might understand. Okay, Let us convert, for example, uh, 87, which is in base 10, to convert it into base 2. Okay, shall I show you this example? Now, by this, you'll understand easily, inshallah. Now, you see, how do you convert this base? It's very simple. Okay, what is the number? 87 is the number. And you want to convert into base 2. So, divide it by 2. Okay. Now, you see, 2 into 2, 4. 2 fours are 8. 2 fours are this 8. And 2 threes are 6. So, 1 remainder. You get 1 as remainder. Okay. Understood this step? All of you. Example 3, first step. How you got remainder 1? 40, you see, 2 goes 43 times in 87 and it gives you 1 remainder. Do you understand, all of you? I'm sure you how to calculate this in calculator. You just divide 87 by 2, you will get 43, correct? And remainder is 1. Is it clear? Yeah, Abdul Khalif, you have any question? Abdul Khalif, you have any question? Okay. So you understand the first step? How we got this 43 and remainder 1? Yes, no answer. Yeah. So now you see, now 43 is bigger than 2. So again, I will divide it with 2. Okay. Again, when I divide, 2 twos are 4, 2 ones are 2. So remainder is again 1. Okay. Now 21 is again bigger than 2. Again, I will divide it with 2. Okay. So 2 goes how many times? 2 tens are 20. Okay. 2 tens are 20. So 1 remainder. So again, I will write 1 remainder here. Then 2 goes how many times? 2 fives are 10. There is no remainder. So remainder is 0. Then next you have 2 2 twos are 4. Okay. So 2 twos are 4. 4 means a remainder is 1 here. Then 2 and 2 are same. Again I will divide 2. 2 goes one time. 2 ones are 2. Remainder is 0. So 1 is less than 2. We will stop here. Okay. 2 is less than 1 is less than 2. We will stop here. Now, how you will take the binary number? From bottom to top. You take from bottom to top. If I take from bottom to top, I get 1 0 1 0 1 1 1. Okay. So this is the binary equivalent of 87. So now the answer is how much? The answer is 1 0 1 0 1 1 1. Okay. This is in binary. So all of you understood this procedure? So if you have in general, if you have any number in base 10 and you want to convert into any base x, so you have to write that number and divide it with x and go on doing this till you get a number n dash which is less than x. Here you should stop. After you stop, take from to top. This will be the equivalent. This will be the answer here. Okay. Yeah, great. So by this we have completed first skill. Okay. Now let us go for second skill. From any base to base 10, how you will convert. Okay. So I'm saving this. So yeah, so I will take solution, continue. Yeah, any questions? No problem. You thought it was with pulse. No, no, it's not with pulse. Okay, it's clear. Great, good. No problem. It happens sometimes. So let us learn the next skill, second skill. Second skill is a number of any base convert into a number to base 10. Okay, this is the skill. So let us take the above examples. Okay, I think we have taken A25, correct? Just now we solved it, A25, and also we have taken 99. Okay, in base 16. So let us see that. Let us take the two examples. For example one, we will solve. Okay, let me just cut this. Yeah, here I will write. Uh, use pen. Okay. So I will take example 1 as A25 base 16, convert this to base 10, and then I will take example 2. Okay, 101011, which is in binary. Okay, convert this into base 10. Okay, so from any base 16 or base 2 or base 7, base 8, whatever it is. Okay, so for that you remember one formula. Okay, how do you convert any base number to base 10? Any base number to base 10, there is one formula. Suppose you have number xyz. Suppose you have number uh, x, y, and z, and its base you don't know, it is b, and you want to convert this number into base 10. Okay, you know the technique is what? The technique is very simple. The technique is uh, first b power 0 multiply by z plus b power 1 multiply with y plus b square multiply with x. Suppose you have big number ABC, then b power 3, b power 4, like this you can go. Okay, you can go on doing that. Okay, this is z. Okay, this is the formula. Now let us apply this formula. We'll apply this formula to our problem A25. So you have A25. Sorry. Yeah. A25. Its base is B is 16. Okay. So this is the number base 10. So how do you get this in base 10? Very simple. 16 power 0 multiply with 5 plus 16 power 1 multiply it with 2 plus 16 power 2 multiply it with A. A is nothing but 10. Please use calculator and tell me how much is it. 16 power 0 is 1. This is 5 plus 16 to the 32 plus 16 into 16 is 256. 256 in 10 is 2560. Okay, so please use calculator and tell me what is the answer. Please send me the answer. Tell me what is the answer. I'm waiting for your response. How much is it? Please add 5 plus 32 plus 2560. So I'm waiting for your response. Very good. 2597. So the answer is 2597 in base 10. See, this is the question which we did in first scale. We converted 2597 into base 16, correct? So this is the verification we have done, that it has been verified that we can change from base 16 to base 10 or from base 10 to base 16. This is very easy. Okay, now let us go for example 2. So this is very easy. How do you convert this number 1010111, which is in base 2, to base 10? Simple. 2 per 0 into 1 plus 2 power 1 into 1 plus 2 square into 1 plus 2 cube into 0 plus 2 to the power of 4 into 1 plus so we did 1 1 1 0 1, again 0 1 is remaining. Okay, so plus 2 to the power of 5 into 0 plus 2 to the power of 6 into 1. Okay, if you solve this entire, you will get in base 10. So let us write another step. 2 per 0 is 1. 1 into 1 is always 1 plus 2 plus 2 to the 4. 4 into 1 is 4 plus 2 cube is 8. 8 into 0 is 0 plus 2 per 4 is how much? 16 into 1 is 16 plus 2 per 5 is 32 into 0 is 0 plus 2 per 6 is 64 into 1 is 64. Okay, now just add them. How much you will get? 64 plus 16 plus 4 plus 2 plus 1. Yeah, tell me what is the answer. What is the answer? I'm waiting for your answer. So much time. Just add 1 2 plus 4 plus 0 plus 16 plus 0 plus 64. How much? Very good. It is 87. So you got 87 base 10, which is that what we solved in first scale. Okay, so 87 we converted into binary as this number and vice versa. Thus we verified also. So now using these two techniques, okay, you can okay, I'll just save it. I will just show you the last skill, which is an application of both. Okay, then we'll go for next problem. So this is first solution. Continued. Okay, now final example. I'm giving you one final example. What is this example? Convert 405, which is in base 6, to convert them into base 8. This is a little bit tricky. Please note down this question. You have to convert 405, which is in base 6, convert into base 8. Okay. Now, how you will do it? First, convert this base 6. Our skill is use, second skill, which is convert this 405, which is in base 6, to base 10. From base 10, you convert it into base 8. Okay. So from any base to base 10, from any base to base 10, and from base 10 to any base. Okay. So these two skills. So let us do first. Let us convert 405 into base 10. So 405 base 6. If I want to convert it to base 10, 6 power 0 into 5 plus 6 power 1 into 0 plus 6 square into 5. Okay. So this is in base 10. So 6 per 0 is 1. 1 into 5 is 5 plus 0 plus 6 6 are 36. 36 multiply with 5. Please use calculator and tell me what is the answer for this. 6 into 6, 36 into 5, 180 plus 5, 185. Okay. So we get the answer as 185, which is in base 10. Okay. So we have completed half of the which is 185. Okay. Now let's come here. Let us convert now 185 to, which is in base 10, to base 8. How do you do? 185, you have to divide it with 8. 8 ones are 8. I'll just use another color. Okay. 8 ones are 8. 8 twos are 16. Correct? 17, 18 to carry. 8 threes are 24. So remainder is 1. Then 8 twos are 16. 17, 18, 19, 20, 21, 22, 23. So 7 is the remainder. And you know that this 2 is smaller than 8. We will stop here. Yeah. After stopping, you have to take the number from bottom to top, which is equivalent to 271 in octal. So therefore, 185 in base 10 from octal is 271. So therefore, we got the final answer here is how much? 271. Therefore, we got the solution as 271. Okay. So by this, we have completed the first skill. Do all of you understand this? If you have any questions, please ask me. No, then I will go for next problem. Any questions now? Okay. Now let us go for problem number 2. What is problem 2? What is microprocessor? Okay. What is microprocessor? So let us answer this question. Now, in order to understand what is microprocessor, first you need to know the block diagram of digital computer. Okay. The main block diagram of digital computer. Just I'll show you the screen. Let me share with you. Yeah. So I'll just open second slide. Yeah. Second solution to the second problem. Okay. Now, see here, you might have seen the block diagram of a digital computer. A digital computer has input unit, okay, and an output unit. And from input to output, we have two things. One is ALU, arithmetic and logic unit, and control unit, okay. And of course, this the block diagram of microcomputer also has primary storage and secondary storage. Okay, so when you combine the secondary storage and primary storage, you call it as a storage unit. Okay, you will call it as a storage unit, and the combination of control unit and ALU, it is called CPU, central processing unit. Okay, so remember that the CPU is a combination of ALU and control unit. Okay, so here I write. Okay, what do you mean by this input unit? Data will be given through input unit. Examples of input units are, you have mouse, okay, your keyboard. These are the examples. Okay, and output unit, you will have screen, monitor. Okay, this is an example of. Now storage unit is a combination of, storage unit is nothing but a combination of primary memory plus secondary memory. Okay, and whereas central processing unit, your CPU, it is a combination of arithmetic and logic unit and control unit. Okay, so I have mentioned here CU means control unit, and this is arithmetic and logical unit. In arithmetic and logical unit, okay, what kind of operations are performed? There are many types of operations are performed: addition, subtraction, multiplication, division. Okay, less than, greater than, less than or equal to, greater than or equal to. Okay, not, equal to. This kind of all operations, logical operations, are performed by your ALU. Okay, now control unit, it is the brain of the CPU. Okay, it control fetching an instruction, decoding an instruction, okay, and then executing an instruction. For executing, it will, control unit will send to ALU. For fetching, it will give signals from where to fetch. Okay, decoding will be done by control unit. All that kind of stuff will be done by your control unit. Okay, so in this diagram, you see the control flow is shown here. From input unit goes to control and output unit. It is controlling, and these are the buses that control unit, get information, get variable information from memory. So they are two bidirectional buses are there. Okay. So now in typical computer, your processing is present in two single chips. Okay. This control unit is one chip and arithmetic logic unit is second chip. Okay. But microprocessor is a single chip in which you have these two things embedded. Okay. So microprocessor is nothing but a CPU built into single IC. A CPU built into single IC. Only one chip is there in which you have control unit and also ALU. Okay, is called as microprocessor. It is also called as, I'll just denote it with this microprocessor. Okay, so all these units, control units, okay, and arithmetic and logic unit, all of them are connected. Okay, all of these units connected entirely in a single unit. In microprocessor, all these units are connected entirely in single unit, or single chip. This is your microprocessor. And a digital computer whose CPU is microprocessor is called as microcomputer. Okay, so note down this very important point. Let me choose another color. Yeah, the last point is a digital computer whose CPU, central processing unit, is microprocessor is called as microcomputer. Microcomputer. Understood? Do any one of you have any question? Do all of you understood? If you have any questions, please ask. Clear. Okay. Now, all of you, I want some question from you. I just display a multiple choice question. Okay. So, give me the polling now. Okay. One question is appearing on the screen. So please, all of you answer. Processor and microprocessor both are same. Do you see this question, all of you? Please give response. I have asked one question. All of you go to the polling and check the question. Yeah, so I got one response. Both processor and microprocessor both are same. I got one answer I'm waiting for four more students to give the answer. Please give the answer. What about others? I didn't see any response. So Abdul Khaliq only has given the response. I'm waiting for others also to give a response. Khalid, Faris, Muhammad bin Saeed. Yeah, great. I got two responses. Yeah, three responses. Still three are pending. After that, I will give you the answer. Okay. Is processor and microprocessor both are same? Good, great. All of you are giving the right answers. Keep it up. Yeah, the correct answer is no, because in processor, CPU and IC both are in a separate unit. Okay, but whereas in microprocessor, it is in a single chip. Great. So all of you have given correct answer. Okay. So let's go for now. Third question. Let us see the problem number 3. Okay, for adding two 32-bit numbers in 8085 and 8086 takes how many clock cycles? See, question number 3 and question number 4 are related. Okay, these two questions are related. So let us solve these two questions now. Okay, see, in this tutorial, we are learning about only 8086 processor. Now, because 8085 is the immediate preceding of 8086, so that's why we, in history, I think doctor has already taught you about all the processors. In that, 8085 also has been discussed. Okay, so we have taken these two processors, 8085 and 8086, and we want to add two 32-bit numbers. Then, in the first question, problem number 4, we need to find out that how many clock cycles are required to execute adding two 32-bit numbers. Okay, so how do you find out that? Let us see now. So I'm sorry, problem 3 and problem 4. We'll be solving problem 3 and problem 4, not 5. Okay, 5 we'll see next week. So these two problems, let us solve and conclude. Okay, so shall we proceed? Yeah, let's go for now problem number 3. So I'll share you with my, yeah. So let's go for new and save it. So here I will go for third solution. Sheet number let us see. The question, I think all of you are having these questions in front of you. For adding two 32-bit numbers, you have two 32-bit numbers. What do you mean by 32-bit number? You have first number 1, okay, whose size is 30-bit. and number 2 is also 32-bit, and you want to add these two numbers, n1 plus n2. Okay, now remember he's asking for two cases. One is for 8085 and another is 8086. Now in order to find out this, you should know the architecture of these two processors. Okay, so let us uh, come that 8086 processor. First let us take 8085 microprocessor. Okay, this is developed in 1976, year 1976, and it is a 8-bit CPU. What do you mean by 8-bit CPU? 8-bit CPU means this CPU has this. Sorry, 8-bit microprocessor means we know that microprocessor is a combination of control unit and ALU. Okay, and the size of ALU is 8-bit. It means this arithmetic and logic unit can perform operation only on 8-bit. Okay, but the problem is here you have to add 32-bit. Now if you want to add 32-bit and the size of your ALU is only 8 bits, so it will take how much? 4 clock cycles. Okay, it will take how much? 4 clock cycles. And some other information about 8085 is it uses frequency of 8085 uses frequency of 3 megahertz, and it uses 40 pins. This extra information. See, in any microprocessor you should know, okay, when it has been invented, what is the size of its ALU and what is its frequency, okay, and how many pins it has, and what are the number of address lines and data lines. Okay, that is also important. Number of address lines in 8085 is 16 and data lines are only 8. Okay, so we solve this first problem. Hope all of you have understood. How many clock cycles? 4 clock cycles. Okay, now second is he is asking for 8085. So let us use some other interesting color. Okay, 8086 microprocessor. Now this 8086 microprocessor, this is it is 16-bit size. It means you have control unit and ALU. The size of ALU is 16-bit. Okay, and you have about the speed. Actually, in 8086 you have 3 standards. Okay, one is normal 8086 standard version. Okay, its frequency is megahertz, and you have another version 8086 version 1. Okay, this is 8 megahertz frequency, and 8086 version 2, it is having I think 10 megahertz frequency. Okay, and this is this is also 48 pins. Okay, 40 pins normal plus extra 8 pins for minimum or maximum mode. Okay, so total you can say it's 48 pins, right? Yeah, and I got some question somebody asked. No, this is not given. This is, you should remember, this is not given. Okay, this you should know. All this what I have written, you should remember this. Okay, this all these things you should remember. You should remember all these things. It is not given. This is what you need to know. Because you are learning 8086, you should know what is the configuration of 8086. Okay, that is the. And also one more thing is address lines. Okay, it has address lines of 20 bits. Address lines of 20-bit and data lines. There is data buses. This is 16-bit. These are very important things. Okay. So from this information, we know that it is for adding two 32-bit numbers. For adding two 32-bit number, the size of ALU is 16. So it will take how much? 2 clock cycles. Understood, all of you? So any question? Okay. So let us go for the last problem, problem 4. Yeah, thank you. Welcome, all of you. So I will go for next problem, which is fourth solution. So let us save this. Let us solve fourth solution. Okay, in fourth problem, what he has given, just recall that. Let us go and check what is there in fourth problem. Yeah. Calculate the time required to execute an instruction that add to. Okay. In the problem 3, he has asked only number of cycles. In problem 4, he is asking to find out time also. Okay. So clock cycle is nothing but its speed. Time is nothing but its frequency. So time is nothing but 1 by f, 1 by frequency. Okay. 1 by frequency is nothing but its time. So it's very simple. Now let's go back to our slide. Yeah, micro. Yeah. Now look here. Let us find out first the time required to add. We have to find out time required to execute time required to execute we have to find out executing what, adding two 32-bit numbers. This you have to find out. Okay, for that you need to know the frequency of, first let us case A, case 1 will take for 8085 microprocessor. From the previous solution we know that the frequency at which this 8085 runs is given as 3 megahertz, right? 3 megahertz. 3 mega is nothing but 3 into 10 to the power of 6 hertz. Hertz is the unit of frequency. Okay, and we sorry. So f is equal to this is 3 megahertz. Now what you have to do is you have to find out the time required to execute this instruction, how much. For that you need to first what is this t? T is the time period, that is time taken for one clock cycle. Okay, t is what? Time taken for one clock cycle. So here I will write t is equal to 1 by f 1 by 3 into 10 to the power of minus 10 to the power of 6. So this will be how much? 1 by 3 into 10 to the power of minus 6. 1 by 3 is how much? 0.333 go on microseconds. Correct? Now we know that this add instruction takes how many? 4 cycles. Okay, so therefore total time 4 cycles multiplied by 0.333 microseconds. You just find out, you will get the answer. Okay, and next let us take case of 8086 microprocessor. Now it has 3 different versions. Okay, standard version and 8086 version 1 and 8086 version 2. Standard version is taking how much? Do you remember? What is the standard version taking? I think it is 5 megahertz. This 5 megahertz, and this is 8 megahertz, and this is taking some 10 megahertz. So if this is not asked, you can find out for any one of them and mention that you found for standard version or 8086 version 1 version 2. It is not given, so I'm finding for standard version. But be careful that when the question is asked, you should mention that if it is mentioned in the question, find out how much time is required for 8086 version 1 version 2, then you should use the corresponding frequencies. Okay, yeah, good, great. 8 and 10. Thanks for your answers. Thank you, great. Yeah, so now I find standard version now. For standard version, okay, frequency is 5 into 10 to the power of 6 hertz. So for one clock cycle, okay, 1 by 5 into 10 to the power of 6, this will give you 1 by 5 is how much? 0.2 microseconds. Okay, then if it is like this, then what you will do is we have to find out, for adding two 32-bit numbers, it is taking 2 cycles. Okay, so therefore total time is 0.2 microseconds into 2, which is equivalent to 0.4 microseconds. Okay, so total time required to execute two 32-bit add numbers, okay, is 0.4 microseconds in 8086 standard version. Hope all of you have understood up here. If you have any questions, please ask. If you have any questions, please ask. Okay, if it is clear, fine. So thank you, and see you next week, inshallah, with problem 5. If you have any question, you can ask me. If you have no question, okay, good day. See you next week. Okay, thank you.